Okay, this last section in this chapter is solving trig equations. We're going to only look for primary solutions, which means the ones that are on the unit circle from 0 to 2 pi. Notice we're going to include 0, but not 2 pi. We're going to use all these identities that we've used, which remember, an identity is true for all x values, no matter what it is. We're going to use those identities to solve equations which are true for some x's, and we need to figure out which ones. That's what solving the equations is all about. So let's look at solving some of these. Let's say we have sine x plus cosine x equals secant x. And we want to solve what x values make that true. What primary solutions do we have? So the best way to do a lot of these is to try to get them in as few different trig functions as possible. So we know secant is 1 over cosine, and we said when we had rational equations and we had things, fractions in the bottom, that what we did was we multiplied the whole thing through by that common denominator, and that would get rid of stuff in the bottom. So if we multiply this through, we're going to end up with sine x cosine x plus cosine squared x equals 1. Now, if we subtract the cosine squared x over to this side, then we see that we have a Pythagorean identity. Okay, if you look at this and you see the squared and the 1, then you can say, well, I can probably get that to be something altogether because those Pythagorean identities. We know that sine squared plus cosine squared is 1, so that means that this is just sine squared. Now, we can move this all over together. We have sine squared x minus sine x cosine x. Remember, we look for a common factor, which we have here, sine x times sine x minus cosine x. When we have two factors multiplied together set equal to 0, then we know we have to have the sine of x has to equal 0, or we know that sine x minus cosine x has to equal 0, which means sine x has to equal cosine x. So now we're looking on our unit circle for what makes this true. Well, sine is 0 at the angles 0 and pi, and the sine equals the cosine at pi over 4 and 5 pi over 4. So make sure you know those unit circles so that you can get those. So your answers are 0, pi, pi over 4, and 5 pi over 4. Of course, you can go up here and check them, all 4 of them, and make sure that it works. And it does. Let's try another one. What if we have secant squared x minus 2 tangent x equals 4? Well, we've got a tangent here and a secant squared. We know that secant squared and tangent squared are related by a Pythagorean identity. So let's take the secant squared and replace it with its Pythagorean identity, tangent squared x plus 1. Now we've got everything all in one trig function. Now if you notice, you've got a squared here, and to the first power, and a constant. That should look familiar, and you think, that's kind of like a polynomial. So let's try to get it arranged like that. We're going to subtract this 4 over here so that we end up with everything on one side and equal to 0. Now, it does look a lot like a polynomial, and in fact, you can factor it just like you would a polynomial. Except instead of having just plain x, we've got the tangent of x equals each of these things. So here we have two factors that equal 0, because if either one is 0, then we end up with the answer we want. So again, we've got to use our unit circle, or we can use our calculators and do our inverse. So we have inverse tangent of 3. And that's going to give you, when you punch it in your calculator, it's going to give you 1.249. Now if you look, 1.249 is over here somewhere. So it's this angle here. The tangent is also going to be that, this one over here, because remember sine and cosine are both negative. So what we do is you take this angle and add pi to it, and it'll give you the other answer. So those are our two answers possible here. Now this one, we know on our unit circle, the inverse tangent of -1. So that happens at 3 pi over 4 and 7 pi over 4. If you can have an exact answer like this, then I want to see an exact answer like this. You have got to know that unit circle. This one, you couldn't have an exact answer because it's not part of the unit circle. So we're not going to do all the work to get the exact answer that's more complicated than just the unit circle for that. So if you see something that looks like a polynomial, you can factor it the same way and work it the similar way and get your answers. Of course, you can check all these and go back to the original and check them, and you should get exactly right. With these, you'll have to be kind of careful how much you round. There's no real way to show you how to solve every single one of these equations. There never will be of any kind of equation. So you're going to have to think and use all the tools that you have. You have a whole big bag of tricks. Trig identities, things you know about polynomials, radicals, logs, all those things that you know. And you just have to use those tricks so that you can get these solved. So let's try another one. This one I want you to try to solve on your own. So once you've written it down, pause the video and work it on your own, and then you can turn it back on and we'll work it together. So go ahead and pause it and work this one out first. All right, so hopefully you have a solution already. And let's see how we get it. We see a squared here and a not squared to the first power here, and we think, well, we could use that polynomial, but the problem is this is a sine and this is a cosine. Well, there is a way to fix that, though, isn't there? Because we could use our Pythagorean identities and replace this so that we have a cosine squared. So now we have 6 minus 6 cosine squared x minus cosine x minus 5 equals 0. Combine my like terms and I get -6 cosine squared x minus cosine x plus 1 equals 0. And again, squared to the first constant. We can factor this. It factors very nicely. Really all you have to worry about is what number we're going to put out here, because plus 1 has to be plus 1 times plus 1. There's no other way to do it. So we just have to worry about what we get here so that our middle term turns out correctly. So we check our middle, -3 cosine plus 2 cosine. That gives us a -1 cosine. So again, we just solve it just like we did a polynomial, except we're going to solve for cosine and then take our inverse. So here we end up with the cosine of x equals 1/3, and here we end up with the cosine of x equals -1/2. And if we take an inverse here, inverse cosine of 1/3, we get that x equals 1.231. So we think to ourselves, well, that's over here somewhere. My cosine is positive in the first quadrant and in the fourth quadrant. So I want this angle too, which means I'm going to take 2 pi and subtract that to get the other value. And I'll get 5.052. This one's on the unit circle, so you should be able to get this one pretty easily. 2 pi over 3 and 4 pi over 3 in the second quadrant and the third quadrant because it's negative. So here's our answers. And of course you can go back and check them, make sure they're right, and make sure it all works out. Remember, we're looking for primary solutions, so we're only looking for those ones that would be from 0 to 2 pi, not including 2 pi. Make sure you've read this section and taken good notes so we can go over it next class.